Hello, Warhawks. This is Mr. Tipton. Welcome back. We're ready for Chapter 6, which we're going to start with Chapter 6-2, which is triangle similarity. The thing you need to remember here is that similar in geometry means the same shape but different sizes. So they look the same in the way their appearance is made because they have the same size angles, but the length of the sides is not necessarily going to be the same. And here's the two qualities that similar triangles have. Number one, their corresponding angles, meaning angles in the same places, are going to be congruent. And the second thing is their corresponding sides are proportional. Let's do a quick review of what it means to be proportional. This is an example of a proportion. It's two fractions that are set equal to each other. So the part on the top has to be the same to the bottom as this part on top, or numerator has to be to this part on the bottom, or denominator. The way that you solve proportions is you cross multiply. So we're going to multiply x times 20, which gives me 20x, and 5 times 4, which also gives me 20. Now solving this algebraically, to get rid of a times 20, I divide both sides by 20, and I get that x equals 1. And you can see how that proportion is true. 1 is to 4 as 5 is to 20. That's what it means to be proportional with sides. We may have triangles that have side lengths 1 and 4, and then another triangle that has side lengths 5 and 20 in the same place. So they would be proportional. You might have a situation where instead of just a variable, you have a number and a variable. But still we cross multiply to solve proportions. 4 times 25 is 100. And 2 times 9 is 18, but it's 2x times 9, so it's 18x. And now we just divide to get the answer. The answer we get here when we divide both sides by 18 to get x by itself is that it's going to equal 5.56 is what x equals. So we could say that 4 is to 9 as 2 times 5.56 is to 25. There's a proportion. Now let's get into similarity. So triangles that are similar have the same exact angles, and their sides are going to be proportional. I'll show you that in a second. So since we have the same angles here, I know that these triangles have the same shape. That's important. That's what proportional shapes or similar shapes have. They're the same shape, but they have a different size. You can see that AB and XY are not the same. So these two triangles would be similar. I would say that they were triangle A, B, C, and the symbol for similar is a little squiggly line, is similar to triangle. And it's important how I list this. Since A is 80, I want to make sure that I list X first since I listed A first. And then I listed B, so B was 60, and Y needs to be the next one because it's the same place as B. And then lastly, I listed C, and C and Z are in the same place. So triangle ABC is similar to triangle XYZ. Now the sides would also be proportional. So maybe this one's 1, this one's, we'll say, 3, and this one's 4, and maybe over here this one's 2, 6, and 8. So you can see how those are proportional to each other. 1 is to 2, it's half of 2. 4 is half of 8, 3 is half of 6. So those are proportional to each other. There's 3 different ways that triangles can be similar, meaning they have the same shape, but they're different sizes. We have angle-angle similarity, which we abbreviate A with the similarity sign. We have side-side-side similarity that's abbreviated SSS with a similarity sign. And then we have side-angle-side, which we abbreviate SAS similarity. And those are the ways that triangles can be similar to each other, or we can prove that triangles are similar to each other. Let me show you what I mean. So here we have angle-angle similarity. It says if 2 corresponding angles in each triangle are the same, then the triangles are similar. So here we have 2 triangles. I can tell that they're not quite the same size, but they do look similar to each other. They look kind of like they're the same shape. This one's one way, and this one's kind of been rotated. But still, in this picture, we see the angle L and angle R are marked similar to each other. So we could say that triangle and also M and Q are similar to each other. So if 2 angles are the same, then the triangles are similar. We have 2 angles that are the same, so these triangles are similar. I could say triangle LMN is similar to triangle Since I said L, I need to write the one that goes with L, which is R, is marked congruent to it. And then I said M. Q and M are the same, so I say Q. And then N and S. Now, it doesn't say that N is the same as S, but you know from triangles that if all triangles add up to 180, so whatever this angle measure is, this is the same, this is the same, so there's only one measurement that these other two angles could be that would make the triangles, that would make the angles the same. So those two triangles are similar, which means that the triangles have the same angles, which we showed, and the sides are going to be proportional to each other, which means like maybe this is 1 and that's 2. Or the other ways that we can have is side similarity. This says if corresponding sides of two triangles are proportional, then the triangles are similar. So we actually have to do some work on this one. I have to check to see if all the sides are proportional. So if I look at these two, it appears that 3 and 9 are in the same place, but I want to be careful. 3 is the smallest side of this triangle, 9 is the smallest side of this triangle. So if they are going to be proportional, those are the two that I'm going to relate to each other. So I say, okay, is 3 to 9 equal to, we'll say the next smallest side is 4, the next smallest side here is 12. Is it equal to 4 over 12? So is 3 to 9 the same as 4 is to 12? Well, we can solve this by cross multiplying. We do 3 times 12 gives us 36. We do 4 times 9, which also gives us 36. So yes, those two sides are proportional. We need to check the last sides. So I can say 3 is to 9 again, as now this time instead of 4, I'll do 5 is to 15. Let's see if those also end up being the same. So let's see if they're proportional. Well, I cross multiply. 3 times 15 equals 45. And 9 times 5 also equals 45. So yes, again, those are proportional. And then lastly, I'd want to check 4 to 12 is 5 is to 15. So I do 4 is to 12 as 5 is to 15. So I check all the sides. 4 times 15 is 60. And 5 times 12 is also 60. So since all of these equal each other, those sides are all proportional, which then means that we know that these two triangles are similar. So I could say triangle A, B, C is similar to triangle X, Y, Z. Not a very good job drawing that triangle there. Kind of hard to draw with the mouse. And what that means for us now is the sides are proportional, but the other thing with similar triangles is that the angles are going to be the same. So whatever this angle is, it kind of looks like 90, this one's going to be the same. Whatever A is, X is also going to be the same. And whatever C is, Z is going to have the same measurement. So we can prove that from knowing that the sides were proportional. The last way that we can prove triangles are similar is side angle side similarity, which is a little different. It says if triangles have two proportional sides, so we only need two this time, and the included angles, angle between the two sides, is congruent, then the triangles are similar. So here we have two side measurements. We have 4 and 7 in this triangle, 16 and 28 in this triangle, and it's important that it is the included angle, which means the one between them. If I had angle Q marked here, I wouldn't necessarily be able to say that these were similar because Q is not between 4 and 7. Neither is R. Over in this triangle, P is not between 16 and 28. It's not an included angle. J is also not between 16 and 28. So it's not an included angle. So the only way this works is that the angle is actually between the two sides that we have are proportional. So we need to now check. So the angles are the same. That's good. That's one thing that we needed. But now we need to see if 4 is to 16 as 7 is to 28. So we check that with the proportion. 4 over 16 equals or is to 7 over 28. And how do we check to see if they're proportional? Well, we just cross multiply. When we cross multiply, 4 times 28 equals 112. So I cross multiplied there. And then when I cross multiply 7 times 16, I also get 112. So yes, those sides are proportional. So since I have two sides that are proportional and the angle between the two sides is the same, I can say triangle, we'll just say LRQ is similar to triangle. Since I said L, I have to say the angle that goes with L, which is B. I said R second. So which one goes with R? Well, I went down the longer side, which was 7, so I need to go down the longer side, which is 28. So B, J. And then I went from R down to Q, so I go from J to P. So triangle LRQ is similar to triangle BJP, which means they have the same angle measures, so Q and P are the same, R and J are the same, and the other side would be proportional. Now, we don't know the measure of this side, but whatever it is, they're going to be proportional to each other. They're going to have that same ratio of 4 to 16 as 7 is to 28, or you can see that they're 1/4 the size of each other. 4 times 4 is 16, 7 times 4 is 28. All right, there you have it. So those are the three ways: angle-angle similarity, side-side-side similarity, and side-angle-side similarity.